In this video we will see how to do transfer learning by freezing some layers from another pre-trained network. So it is very common to benefit to take advantage of some other networks that were trained for some other task, but then you freeze most of an interesting part of that network and you put on top of that a network that will solve your task. So here it is an example in which I'm using VGG16 that has this convolutional architecture, and it was originally trained on 1,000,000 images with this size RGB images with 1,000 labels, and we want to apply it to recognize numbers of MNIST, so just digits, where we have many less images, so we couldn't afford to train so many coefficients, and there are smaller gray images, and we only want to distinguish between 10 labels. So our network will be made of two parts. The first part will be some frozen layers from ImageNet. The second one will be our own neural network that tries to solve from the latent space of the previous one. We try to solve this classification task. So let's see that at the level of code. So the idea is that when we load the data, we have to put it in the same way as the original network was meant for. So the original network was meant for images of size 224, and then it was RGB images, and they were normalized to be within a certain range. So we have to do the same. And so we load the data, and while loading we are applying this transformation, and then we load the VGG model. In the VGG model we are saying I want the pre-trained weights, and then what I'm saying here is all the parameters from these layers, they do not require gradient. That means they will not be optimized. Then we substitute the classifier for MNIST. So that we replace the classifier of VGG to be a classifier for MNIST. So this classifier is one of the layers of VGG. So you need to know what is the structure of the internal structure of these objects. But yeah, you can load and then explore the objects by yourselves. So you put your architecture for the classifier, and then this is simply defining the cross entropy loss, the optimizer, moving the model to the GPU, and then we will train for just 5 epochs, and we will compute what is the output of this model that has our modified classifier on these images. We compute the loss, and we optimize, and that's it. So we can see how the loss behaves, and yeah, the accuracy is 99% of the digits are correctly classified. You have here the predicted and the true value, and the key thing here is that this is transfer learning. So most when you process images or many other domains, it happens the same. So for instance, with images, what happens is that the first layers they learn very low level features, like some kind of bandpass filters or oriented filters, kind of that. So if VGG16 has been trained on 1,000,000 images, probably the first layers, they are useful to capture useful features of images, of the input image. So now what we are doing is we are taking those useful features and training another network on those useful features. But because we don't have so many images here, we can benefit of all the images from ImageNet to freeze the convolutional layers, so that the features that we look into in images, they are somehow fixed by a bigger set of images. So this is very much used in many domains, especially image processing. I hope you can benefit from it. Here it is an example in PyTorch. We don't care about the library itself, but just for you to get an idea of what you have to do.